People here in the war room often ask questions whenever I post videos about aviation from World War II or World War I. It's the following. How did those planes fire their machine guns through the propeller, through the engine's propeller? How did they do that without shooting their own propeller and, of course, without causing their own crash? In fact, some comments are skeptical that this could even be possible. But today I'm going to explain to you how this was possible, how it was perfected, and how it was used until the end. And was it simply discarded because it became an obsolete technology? First, for us to understand the problem, let's understand the scenario that produced this technology. Airplanes were invented in the first decade of the 20th century. Then there's still an open discussion about the true pioneering of the Wright brothers, Santos Dumont, and other inventors that you might not even know that they exist. But they also dispute the creation of the aircraft. Shortly after, these first airplanes became something relatively safe and easy to operate. The United States Army in 1912, which, by the way, had bought its first aircraft just a few months earlier, put a machine gun on the airplane for the first time. Actually, this setup was done in a very ad hoc, very non-traditional way, simply right in front of the passenger who sat next to him. So, on that flight, this passenger activated the machine gun, firing at a piece of white cloth that was on the floor, obviously simulating a target. And when that plane landed, they went to do it there. The accounting of how many shots had been fired and how many had actually hit the white cloth. It was found that about 12% of the bullets hit the target. That sparked curiosity, leading many to question if mounting a weapon on an aircraft was truly reliable or feasible. 2 years later, the First World War begins, and the countries that were competing in that conflict, they all used airplanes, but still didn't know how to properly militarize those planes. In those first months, airplanes were used almost exclusively for reconnaissance purposes, and also as artillery observers, something that balloons had already been doing since the previous century. The first bombs were dropped from aircraft, and they were dropped manually. The guy would literally take the bomb in his hand and drop it outside, and then the bomb would fall and hit the target. In the same way, the first firearms that were fired in World War I from aircraft were personal weapons, like pistols, which the pilots themselves carried for self-protection in case they fell behind enemy lines. So that's how these aviators started shooting at each other. And suddenly, someone had the idea to mount machine guns on these planes. Since the engine had to be in the front, the next step was to try to mount these machine guns with a rear-facing gunner. This guy would sit behind the pilot in the middle of a ring, in the middle of a hoop, and his machine gun was mounted on that hoop. He could even shoot in a pretty wide firing range. But even this solution didn't prove very satisfactory for the aviators, who were eager to shoot at enemy planes by pointing their own plane at the enemy. And not just a machine gun that was back there, which they didn't even have direct control over. And it was to solve this problem that the first wild attempts started to be developed. The one most worth highlighting was the one carried out by the Frenchman Roland Garros, that same guy whose name is now associated with the great tennis tournament, and you might not know that. But he was also a fighter pilot during the First World War, and a close friend of an aircraft designer named Raymond Saunier, a co-owner of Morin Saunier, which made fighter planes for France in both world wars. And Garros developed the installation of some metal plates that were placed there halfway up the propeller blades, exactly at the height of the machine gun. And these metal blades had the function of deflecting the shots that hit directly on the propeller. He tested this solution in flight, in combat, and achieved very good results. And mixed in there, it wasn't as efficient as he thought. Even though a large part of the shots fired by the machine gun really did pass between the propeller blades. But this system was quite inconvenient and also prone to catastrophic failures, so it wasn't something permanent. Roland Garros then devised a better way to solve the problem of firing through the propeller. So he went to research some patents that had been approved in the years immediately before World War I, but that had never resulted in anything. Fragile, no working prototype. He saw the blueprints and got an idea, and he started to assemble on his plane a prototype of a synchronization system for shooting through the propeller. I must point out that this was not yet a functional system. Garros was conducting the first tests of an idea he had, but on April 18, 1915, he was returning, flying over territory occupied by the Germans, and he was shot down. But he made a forced landing and tried to destroy his aircraft, which contained the prototype of his precious new system, which was also supposed to be a state secret. But he couldn't destroy the entire aircraft, being captured by the Germans and taken to prison. When were these wreckage pieces from Garros's aircraft with this new system captured and taken to Germany? They were shown to a young engineer of Dutch origin who worked in Germany, named Anthony Fokker. Fokker was only 25 years old, and for a few months now, he had been thinking of a solution to solve the same problem that Garros was trying to fix. And when he looked at that prototype on that half-destroyed aircraft there, he got the final inspiration to create his own system. Finally, a gun synchronization system through the propeller, which he named Stangensteuerung. You might be thinking that this system would interrupt the machine gun's fire when the propeller passed in front, but that's not the case, and I'll explain why. These German machine guns were generally the Maschinengewehr, 8 Maschinengewehr Art, which had a firing rate of about 8 shots per second. But the engines used by Fokker in their aircraft spun at a much higher frequency than that, making it very likely that the vast majority of the machine gun's shots would be intercepted by the blades. So, for us to start understanding this system, let's start from the principle that the machine gun on aircraft, which is an automatic weapon, started to be used as a semi-automatic weapon. And to explain a very important part of this system, it might be interesting to use the analogy of car mechanics, especially there on the camshaft in the cylinder head, which has those irregular discs that we call cams or eccentrics. As that shaft rotates, it forces the opening and closing of the valves, and the Fokker system uses a very similar principle. Right behind the aircraft engine shaft, Fokker adapted a large disc, camy with 2 protrusions that were positioned 90 degrees from the propeller blades. And on the machine gun, he adapted a rod to the trigger that should come right above this camy, with a protrusion facing downwards. During the entire flight, or normally this protrusion stayed away, it didn't touch the camy, keeping the machine gun still. When the pilot found the target and wanted to shoot, he would first point the entire aircraft towards the target and then pull his trigger. His trigger then makes that rod go down and touch the camy, which is mounted behind the engine. So when that protrusion, which is at 90 degrees from the propeller blade, touches that rod, it activates the gun, and the gun then spits fire, while the propeller is at 90 degrees out of the line of fire. This process keeps repeating throughout the entire combat whenever the pilot wants to fire a burst at the enemy. This system by Anthony Fokker went into combat in July 1915, just 60 days after the capture of Garrett, equipping the Fokker Eindecker or Fokker monoplanes. This led to a period of 6 months of air supremacy, during which German pilots had a huge advantage over the Allies. And this period became known as the Fokker Scourge. This German system was very basic, but it worked, even though it had to be calibrated for each individual aircraft. And eventually, in the following months, German aircraft carrying this system were also captured by the British and French, who developed their own versions a few years later. And they ended up making the machine gun synchronizer through the propeller become a standard for both sides of the conflict. By the end of World War I, the Germans themselves had developed better systems over the last years of the war. And at the very end of it, in 1918, they were already about to replace the mechanical and hydraulic system they used as a trigger with an electric system. This electric system was only brought back in Germany. The foundation of the Luftwaffe in 1935 equipped all the main German fighters with it until the end of World War II. Interestingly, the synchronization system through the propeller started to fall out of use by the late 1930s. Here, in the West, even though Germans, Italians, Japanese, and Russians continued to use the system until the end of the war. But in the West, it was realized that these .30 caliber rifle machine guns would be insufficient to bring down these new large four-engine metal bombers. So fighter plane designers began to focus on mounting heavy .50 caliber weapons only on the wings of the aircraft. So much so that you notice the last American fighter that used weapons above the engine, firing through the propeller, was the Curtiss P-40. In the immediate years after World War II, the Soviets still used this system in their frontline fighters, Lavochkin and Yakovlev. But the system was permanently retired with the introduction of jet aircraft. So did you like the explanation? If you did, then share this video with your friends. Don't forget to give a thumbs up below and also leave your comment telling us what you thought. I'll stop here, big hug, and see you next time.